Alright, I wanted to work another example here with you. So this is BCA table round 2. I have a similar reaction to the previous video, but a little bit different. So it says 2.5 moles of barium react with an excess amount of oxygen gas to form, and then I leave that blank again. So again, the first thing I should do is probably write the reaction. And so I know that barium is reacting. I'm reacting that with an excess amount of oxygen gas. Okay, well if that's oxygen gas, I know the formula for oxygen gas is O, but I also know that oxygen gas is diatomic. And so it's just like that. And then I got my arrow. And what type of reaction is this? Well, I've got an element plus an element. That is a synthesis reaction. And so therefore the formula for this should be barium oxide. And so I would write the formula for barium oxide. It would be BaO. The reason it's BaO is because barium has a positive 2, oxide has a negative 2, and so therefore, to balance it, I just need to put a 2 there, and then I need to put a 2 there. So that is my balanced chemical reaction. I'm going to space these guys out just a little bit more, so I got a little bit more room. Oop, not that much. There we go. Okay, so now, what I want to know, and this is what I'm going to start encouraging you guys to do, is, I can fill in something on this table before I even start. Know that that's going to be 0 particles to begin with, because before the reaction you have 0 products, so that's no big deal. Now, what I'm going to recommend that you do is read the problem, identify what's given. So it says 2.5 moles of barium. Okay, so which one of these is barium? Well, it's right there. That's going to be present before the reaction. So 2.5 moles of barium would go right there. It says it's reacting with an excess amount of oxygen gas, but it doesn't tell me how much oxygen gas there is before the reaction. And honestly, I don't really care, because this problem says how many grams of product will form. So I want to know, essentially, I want to know this guy down here. I want to know how much product is actually going to form after the reaction. So now the question is, before I get going too much here, the question is we've been doing problems where that's 0, so I assume that's 0. The question that I have for you is, did I fill this out correctly this far? Did I put 2.5 in the right place? Yes, I did. But the question is, should I have 2.5 moles in that table? Yes, you should, because I think I still have it down here. Maybe not. The key thing about BCA tables is you have to include units in the BCA table that indicate the number of particles. So the question is, do moles indicate the number of particles? The answer is yes, it does, and so therefore it's okay. And so therefore it's okay, so therefore I can just do everything like I've done before, moles, just like that. Well then, if I come over here, I now can use my stoichiometric knowledge to figure out what this would be over here. Well, what's my ratio? Once I got one thing on the change line here, I can figure out every single one here along the way. And so what's my ratio from barium to barium oxide? Well, that's a 1-to-1 ratio. So therefore, if I'm losing 2.5 moles, I'm going to be gaining 2.5 moles. Let me delete some of this here so it tabs over a little bit more. There we go. Which means that afterwards, you are going to have 2.5 moles of product. Now, additionally, didn't ask me for this, but thought it'd be a good review for mole ratios. What is this relationship here? That's a 2-to-1 ratio, which means that if I wanted to fill out what this change would be, this guy being twice as much as this guy, so therefore I would want to have this guy to be able to figure out how many O2s are changing. So half of 2.5 is 1.25 moles. Let me do that. And so therefore, I know that I'd be losing half of that. Okay? Now, voila, that's just a fun fact, though. But down here, voila, I got my information, right? I've answered the question. Careful, because it's very important to pay attention to the units. This says grams. Is that in grams right there? It ain't grams. You're like, oh, rats, I got to get this in grams. Well, to get this in grams, it's just simple little work proportion. All you got to do is look on the periodic table and you find the molar mass of barium. I don't have my periodic table, so I'm going to use this. I'll say molar mass of barium. Again, you can just find it on the periodic table. Is 137. And so 137, the units on that is grams per mole. So that's 137 grams per mole. Barium's molar mass is 137 grams per mole. And according to my formula up here, I've got 1 barium and 1 oxygen. And so therefore, oxygen, I know, because I use it so much, has a molar mass of 16 grams per mole. So therefore, what's the molar mass of barium oxide? Well, the molar mass of barium oxide would be 137 plus 16, which is, of course, 153. So 153 grams per mole. Well, what does that mean? Well, that means that if I have 1 mole of a substance, it's going to be 153 grams. And so therefore, I'm just going to set up a basic proportion. 153 grams per 1 mole. Then over here, let me just get my division signs going. That over that, then I can set up my equal signs. By the way, my equal signs are very terrible. I apologize. There we go. There's my division sign there. When I set up my proportion here, well, what's going to go on top? Well, let me just ask you, from this information, do I know how many grams? No, that's what I'm trying to know, is I'm going to call that X. Down on bottom, do I know how many moles there are? Well, sure. I know that I have formed 2.5 moles. So then how do I solve for X? It's just a simple cross multiplication. When you take 153 times 2.5, you get 383. So the correct answer is 383 grams, and that is your final answer. So the key thing is, remember, going forward, if you're going to use a BCA table, make sure it's in moles. So you may have to convert from grams to moles or moles to grams at some point, but make sure you're dealing with the unit moles.